Picture a completely silent math classroom. Like if you look through the little window in the door, you see 30 heads just bowed in concentration.
Yeah, pencils are moving, pages are turning.
Right. Everyone is perfectly well behaved. I mean, it looks like the absolute ideal learning environment, doesn't it?
It really does. It's what we've all been trained to look for.
But according to the data we are looking at today, well, 80% of those kids are not doing any actual thinking at all.
It is just a staggering reality.
It totally is. And welcome to today's deep dive. Because whether you are a learner trying to, optimize your own study habits, an educator, or just insanely curious about how the human brain actually acquires knowledge, we have an incredible stack of sources to go through with you today.
We really do. We're pulling from extensive educational research on cognitive architecture, Peter Lujadal's framework on thinking-based mathematics.
Which is fascinating, by the way.
Oh, absolutely. Plus the National Research Council's proficiency standards and some really cutting-edge data on how artificial intelligence is currently upending mathematical benchmarks.
Right. So our mission today is to really unpack this illusion of learning. We're going to explore why mere compliance often masquerades as comprehension and reveal why the messy process of thinking is actually the only true measure of education.
Because the central tension here is that getting the right answer in math might actually be the ultimate disguise for a complete lack of learning.
Okay, let's unpack this. Because that 80% statistic is wild. If 8 out of 10 students in a traditional classroom aren't thinking, what exactly are they doing with those moving pencils?
Well, they are engaged in behaviors that are specifically designed to avoid the discomfort and really the cognitive load of actual mathematical reasoning.
Which makes sense. I mean, math is hard.
Exactly. The research categorizes these behaviors into this taxonomy of non-thinking, which is collectively known as studenting.
Studenting. I love that term.
Right. These are actions that basically maintain the appearance of compliance without any of the substance of learning.
Reading through this taxonomy in the sources, I was definitely guilty of a few of these back in the day. Let's give these behaviors some room to breathe, because I think you listening right now will instantly recognize them.
For sure. So the first category is slacking, which accounts for about 5% of students. This is just overt refusal.
Like the student staring at the ceiling?
Or their head is down on the desk.
Yeah.
They aren't doing the work, and they're making absolutely no secret of it.
They're just opting out.
Right. But the next category, stalling, is much more subtle. And that's about 10 to 15% of the behaviors.
The stalling tactics are incredibly relatable. It's the student who suddenly desperately needs to sharpen their pencil, and it takes 5 minutes.
Or they need to reorganize their entire binder by color code before they can possibly start problem number 1.
Yeah, or they have an urgent need to go get a drink of water. Like, it provides immediate psychological relief because it delays the onset of cognitive work.
Totally. And then the research identifies faking, which is another 10 to 15%. Faking requires a bit more active performance.
How so?
Well, this student looks incredibly thoughtful. They are maintaining intense eye contact with the textbook. They're holding a pencil hovering just over the paper.
Maybe flipping back and forth between pages.
Exactly. But they're producing absolutely nothing. The entire goal of faking is just to avoid triggering an intervention from the teacher.
But wait, if we add up slacking, stalling, and faking, none of those behaviors actually result in a finished worksheet, and yet classrooms are turning in completed assignments every single day.
Which leads us to the most prevalent and really the most dangerous behavior, which is mimicking. A massive 50% of students fall into this category.
50%.
Yeah. Mimicking is when a student successfully solves a problem by simply replicating the step-by-step procedure the teacher just demonstrated.
But without grasping any of the underlying logic. Yeah.
Exactly. They're just swapping out the teacher's numbers for the worksheet's numbers, step by step.
Okay, let me push back on this for a second, just to play devil's advocate. Because when we talk about a math classroom, the working memory demands are huge.
Oh, they're massive.
Right. So if a student's cognitive load is completely overwhelmed, isn't faking or mimicking just a natural survival mechanism? I mean, aren't they just trying to survive a 45-minute class without looking foolish in front of their peers?
What's fascinating here is that the empathy in that perspective is totally valid. But the outcome of that survival mechanism is incredibly destructive.
How so?
It's kind of like putting a bucket under a leaky roof. I mean, you survived the storm today, but the house is still rotting. And the traditional instructional model, what the sources call the I do, we do, you do model, is actually what causes that structural rot.
Walk us through the mechanics of that. Why does that model cause mimicking?
Well, think about the structure. The teacher stands at the front and models the perfect solution path.
Right.
The teacher is doing all the cognitive heavy lifting. The cognitive demand is entirely localized at the whiteboard, and the students are positioned as passive receivers.
Just sitting and watching.
Yeah. So for a struggling learner, stepping outside of that modeled procedure to actually think through a complex problem, well, it feels incredibly risky. Failure in a classroom is public, and it's embarrassing.
So mimicking allows them to survive a high-stakes environment by producing the right answer.
Exactly. It protects them from the vulnerability of true intellectual struggle.
So the data is showing that only about 20% of students are engaging in the final behavior, which is trying on their own, like actually grappling with the problem, experimenting, and persisting.
Just 20%, yeah.
But this brings up a massive question. If half the class is just surviving by copying steps, how are they passing tests? Like, how are the grades often so high? They must be learning something, right?
They are. They are acquiring a very specific and very fragile type of knowledge. The National Research Council sources draw a really hard line between two concepts here: procedural fluency and conceptual understanding.
Okay, break those down for us.
Sure, procedural fluency is knowing the how. It's the ability to execute operations efficiently. Conceptual understanding is knowing the why. It's grasping the interconnected principles that actually govern the math.
And mimicking prioritizes the how.
Completely. It prioritizes procedural fluency while bypassing conceptual understanding entirely.
The sources gave a brilliant concrete example of this using just basic subtraction. So the problem is 72 minus 69.
Right, a classic problem.
Yeah. And a mimicking student will look at that, write it out vertically, and recite the rule. They say, okay, 2 minus 9, I can't do that. So I cross out the 7, I make it a 6, and I put a little one next to the 2 to make it a 12. 12 minus 9 is 3, 6 minus 6 is 0. The answer is 3.
And they get the correct answer. The worksheet looks perfect.
But the illusion breaks the moment you ask that student why they crossed out the 7.
Exactly. The research points out that a mimicking student has absolutely no idea. They have hoarded the steps of the algorithm, but they do not understand that they are actually decomposing a set of 10 into 10 ones.
Yeah, they just don't see the numbers as quantities representing physical amounts.
No, they just see discrete, meaningless symbols to be manipulated according to a memorized rule.
It's like following a GPS turn by turn. You arrive at the right destination, so you think you know the city, you feel totally confident.
Right.
But if there's a detour or your GPS loses signal, you are completely stranded because you don't actually know how to read a map. You don't have a mental model of how the streets connect.
And the sources refer to this as fragile knowledge. It explains that endless cram and dump cycle where students pass the test on Friday, but forget everything over the summer.
Because there's no foundation.
Exactly. The conceptual map is what acts as a safety net. If you forget a procedural rule, but you understand the concept of quantities and decomposition, you can reconstruct the steps yourself.
But without the concept.
Without the concept, if you forget the rule, you're just left guessing in the dark.
So if mimicking is essentially just following the GPS, the research suggests that teachers, despite having the best intentions, are often accidentally programming the route. How does an educator unintentionally act as an accomplice in this illusion of competence?
It really comes down to the subtle mechanics of classroom dialogue. The research differentiates between two types of teacher questioning: funneling and focusing.
Okay, funneling sounds problematic.
Funneling is a procedural trap. It happens when a teacher asks a series of highly specific, step-by-step questions to guide a stuck student to a predetermined answer. The teacher is basically leaving a trail of breadcrumbs.
You can picture the exact interaction. Like, a student is stuck on an algebra problem, and the teacher walks over and says, okay, look at the parenthesis. What do we do first? Do we distribute the 3?
And the kid just nods and says yes.
And then the teacher says, great, and what is 3 times x? And the student replies, 3x.
Right. The student gets the right answer, but the teacher is still doing all the cognitive heavy lifting. The student isn't thinking, they're just complying with the prompts.
So it's the alternative.
Focusing questions. These push the cognitive load back onto the student. A focusing teacher looks at the stuck student and asks, why did you choose this path? Or what makes this problem different from the one we did yesterday?
Let me jump in here because when you are a teacher or even a parent sitting at the kitchen table helping with homework and you see a kid just completely paralyzed and getting frustrated, I mean, it feels incredibly cruel to just watch them struggle. Isn't a teacher's literal job to step in and help them get to the answer?
This raises an important question about the nature of learning itself. We have to look at Lev Vygotsky's concept of the zone of proximal development, or the ZPD.
The ZPD.
Yeah. It is the sweet spot between what a learner can do independently and what they cannot do, even with help. The goal is not to abandon the student to endless frustration, that is, destructive struggle.
Right. Nobody wants that.
Exactly. The goal is productive struggle. When an adult swoops in and simplifies the task by funneling the student to the answer, they are rescuing them. But rescuing prematurely terminates the thinking process. It lowers the cognitive demand to zero.
The sources laid out this incredible scaffolding method called the 3 reads protocol to handle this without rescuing the kid. And I want to explain it because it totally reframed how I think about word problems.
Oh, it's a fantastic method.
So let's say you have a dense math problem about a farmer building a fence with specific dimensions and costs. A mimicking student usually just stands the paragraph, grabs the numbers, and starts randomly multiplying or adding them just to produce something.
It's a classic coping mechanism. They're ignoring the context entirely,
But with the 3 reads protocol, you stop them from touching a pencil.
which is so hard for them.
Very hard. The first time you read the problem together, you cover up the numbers. You just ask, what is the context of this story?
Right, so the student has to articulate, it's about a farmer trying to enclose a space.
Exactly. The second time you read it, you uncover the numbers and ask, what are the quantities we are measuring? The student identifies lengths, widths, and dollars.
And then the third read,
Only on the third read do you ask, what mathematical questions could we solve here based on this information?
notice what is happening there mechanically. You are forcing the student to build the conceptual map before they're ever allowed to touch the GPS. You are maintaining the cognitive demand, proving that the struggle to understand the structure of the problem is the actual learning. The final calculation is just the postscript.
Here's where it gets really interesting, though. We've established that the traditional classroom is highly susceptible to functioning as an answer production factory. But what happens when we introduce a technology that produces perfect procedural answers instantly?
Well, we are talking about the massive disruption caused by large language models, or LLMs, and agentic AI.
Right.
For context, agentic AI refers to systems that don't just chat with you, but can actually use tools, write code, and take autonomous actions to solve complex goals. And these systems are currently saturating mathematical benchmarks.
The sources mention the AM, that's the American Invitational Mathematics Examination. This tests Olympiad-level reasoning. And these AI models are hitting scores that rival human gold medalists.
It's incredible.
It takes a student's ability to student or mimic to an astronomical level.
It really does. It creates a severe crisis for the traditional educational model. If a student can just snap a photo of a complex polynomial and get a perfect step-by-step breakdown in 2 seconds, the danger of what researchers call knowledge encapsulation becomes critical.
Knowledge encapsulation. We need to unpack that. What exactly does that mean for you, the listener, or for a student in a classroom?
Think about your own workday. Think about the last time you asked ChatGPT to write a complex Excel formula or a Python script for you. You copy it, paste it, it works perfectly, and you move on.
Guilty as charged.
Right. You got the right answer, but did you learn the syntax? No. Knowledge encapsulation means you are outsourcing the friction. In a classroom, when a student uses AI to bypass productive struggle, they are skipping the exact cognitive friction required to physically form neural schemas in their brain.
Using AI just to get the math answer is like having a robot do push-ups for you. Like the push-ups get done perfectly, the form is flawless, but your muscles don't grow a single inch. You haven't gained any actual strength.
That's a great analogy.
But the data reveals a secondary crisis here, which is that the AI itself is suffering from an illusion of learning.
Yes. The reasoning illusion. This is absolutely vital to understand. We project human logic onto these machines, but fundamentally, large language models are just incredibly sophisticated next-word predictors. They operate probabilistically.
So they don't actually know math.
No. If you prompt an LLM with 2 plus 2 is, it predicts 4, not because it has a conceptual understanding of quantities, but because the statistical probability of 4 following those words in its training data is nearly 100%.
The sources highlight a benchmark test called GSM Symbolic that exposes this beautifully. Researchers took standard grade school math problems that the AI could solve flawlessly, but then they made tiny variations.
The subtle changes.
Yeah, they changed the name of a character in the word problem, or they added a single irrelevant number to the background details of the story.
And the AI's performance often plummeted. Because it is doing exactly what the human mimicking student does. It is using pattern matching. It is replicating reasoning steps from its training data without grasping the underlying conceptual truth.
The sources mention that the AI lacks an internal notion of a deductive state. What does that actually mean in plain English?
Well, if you are solving a logic puzzle or a Sudoku, you have an internal map. You know that if you put a 5 in this box, it definitively means a 5 cannot go in that box. Step B relies on the absolute verified truth of Step A. That is a deductive state.
Okay, I follow.
An LLM does not possess that internal map. It generates Step B because Step B looks statistically similar to text it has seen before. So if we allow human learners to rely on AI to bypass their own productive struggle, we are essentially training humans to be as fundamentally fragile in their knowledge as a flawed, probabilistic algorithm.
Which is terrifying. So what does this all mean? How do we use this incredible technology without completely atrophying our own minds?
The research points heavily toward the development of Socratic AI tutors. These are AI systems engineered with what developers call necessary friction.
Necessary friction, which means they are programmed to be incredibly frustrating to a student looking for an easy out.
Pedagogically frustrating, yes. They are explicitly instructed to be adverse to human persuasion. If you ask a Socratic AI for the final answer to a calculus problem, it will flat out refuse.
Wow.
Instead, it leverages those focusing questions we talked about. It insists on questioning the student, forcing them to explain their steps, defend their logic, and spot their own errors. It acts as the ultimate focusing teacher.
It refuses to let you follow the GPS. It makes you draw the map.
Exactly.
But this fundamentally breaks how we currently grade students. If a machine can generate the mathematically correct answer instantly, then correctness is completely obsolete as a metric for human learning.
It really is. It
Yeah.
demands a total shift toward process-oriented assessment. We can no longer just look at the X-ray of the final worksheet and grade the product. We have to evaluate the cognitive architecture.
Meaning how they got there.
Right. How does a student defend their reasoning verbally? Can they identify a subtle error in a machine-generated proof? Can they collaborate with peers to model a real-world scenario? We have to measure the messy journey, not just a pristine destination.
Which brings us to the core of what we are unpacking today. Thinking is the true measure of learning. Whether you are a professional prepping for a high-stakes boardroom presentation, an adult trying to learn a new coding language, or a parent sitting at the kitchen table helping a kid with math homework, you have to ask yourself, are you actually building a conceptual map, or are you just blindly following the GPS?
Are you engaging in the friction, or are you just studenting?
Exactly.
We have to stop rewarding the appearance of knowing and start rewarding the deeply human process of figuring things out.
I love that. And it leaves us with this final paradigm-shifting idea directly inspired by our deep dive into these sources today. We are living in an era where machines can perfectly calculate almost any formula you throw at them, instantly.
Which is amazing, but also intimidating.
Totally. Human intelligence is no longer about just finding the right answer. Perhaps the ultimate test of human brilliance moving forward will be our ability to look at a flawless, highly confident machine-generated output and have the uniquely human intuition to pause, lean in, and ask, wait, why does this feel wrong?
Because that intuition, that conceptual safety net, is the one thing a machine cannot simply pattern match.
And that's all for today's deep dive. Keep building those maps, embrace the struggle, and we'll catch you next time.